state for me your name and what you do and where you work.
Okay, my name is Paul Clarer. I'm from Sandia Laboratories in Albuquerque, and I work at the Robotic Vehicle Range. And we do mobile robotics technologies for various government agencies, including the Department of Energy, several DoD customers, and we're working on getting together with NASA. It hasn't happened yet, but
Is this a big office? Do you have a lot of people working with you?
we've got about a dozen people or so. We may be up to about 15 people in that lab. Our facility is about 200 acres of open mesa on Kirtland Air Force Base, and we've got a series of test tracks and test facilities, and we've got a fleet of about a dozen different robots ranging in size from about 2 feet by 2 feet up to a 5-ton military truck.
And these are used for a variety of purposes, I suspect.
Yeah, everything from robotic landmine detection and clearing, research and development in that area, and security robotics. And some of the more esoteric work I'm involved in is potentially would be lunar exploration rovers.
Now we've got a robotic vehicle here called RATLER 2. What's behind the name?
RATLER is the Robotic All-Terrain Lunar Exploration Rover. And this is RATLER 2 because this is the full-scale 1-meter version of the RATLER. This is our first full-scale version. The original models were on the order of about 12 to 14 inches long, and so this is the first of its kind at this scale, and we brought it out to White Sands to do some testing in the dunes.
How does it work?
You mean how well does it work, or physically how does it work?
Both.
It seems to work reasonably well. The way it works is 4 independently driven electric wheels, electric motors, and if you'll look, it's made up of 2 separate body segments with a pivot between them. It's just a passive rotation joint, and that allows the robot, when encountering rough terrain, to keep all 4 wheels on the ground. And that's the main advantage of this passive joint, is that it allows all 4 wheels to maintain torque. At least that's the theory.
So there's a motor on each wheel driving it?
That's correct.
Okay. And battery powered, I assume?
Yeah.
Now, would something like this work on the moon theoretically?
Yeah, that's the idea. We're designing, hopefully to get a ride and drive it around on the moon as part of a lunar exploration program through the Space Exploration Initiative.
Now, the mechanical part, the motors and wheels and stuff, is probably the easy part. Controlling it's a little more difficult.
Well, I guess comparatively easy, although when you start talking about space-qualified hardware and minimizing launch mass, the mechanical systems tend to get more and more difficult to do. So, mechanically, yeah, mechanically it's very simple. Yet, when you're trying to put a system together that's going to work for 2 years on the moon, and you've got to be able to launch this on an existing expendable booster, it becomes quite a challenge to keep the launch mass down and the power up. And we haven't gotten to the software yet, but we've done software on other vehicles. In fact, you saw Dixie earlier. That's an example of one of our systems.
So theoretically, you could have this thing on the moon for several years, and it could be exploring all over the place.
That's the plan. The point design right now is to design a system that will last on the order of 24 to 27 lunar cycles, so that's about 2 years or so.
And, I mean, how many miles could it cover in that period? I mean, could it go...
It's not clear. The answer to that question really depends on what kind of battery technology we can get and fly, because it's totally electric powered. And batteries are heavy, and they're not a very efficient way of carrying power around compared to internal combustion engine, but that's what we're stuck with. And so the overall range of the rover is dependent on how efficient you can make your systems and how compact power density-wise you can get batteries. It's not clear what the range is. I think it's on the order of magnitude of hundreds of kilometers over the lifetime of the rover, I think is probably reasonable.
So when Martians land up there, we'll be able to observe them land?
That's right. We'll be able to have claimed all the parking rights, and we can make big bucks on the moon.
Thanks. Okay. leave them alone. Let them do their thing.